Controller systems have a lot of moving parts, and there are a lot of threats associated with them. Stick around to learn what they are.
You're watching IT Pro TV.
Hello, ladies and gentlemen. We're continuing through the CySA Plus journey. That's right, and we are talking controller systems here. Now, you know, Dan, it's interesting because I've taught some compTIA courses, and we've dove into the pieces like things like industrial control systems, programmable logic controllers, remote telemetry units, all of these different moving parts that are in these systems. Dan, is that something that we're going to have to know about?
Yeah, you do need to have some basic understanding of ICS SCADA systems because you need to be able to have that conversation with the terminology that surrounds them before we can actually move into threats. So let's start right there with industrial control systems. These are large-scale systems that control things like water and power, health services, national security, even nuclear facilities. We see them every automation when it comes to like automotive industries, things of that nature, right? Where it would be not a good idea for us as humans to be right there in the thick of it, trying to work with these things. That we need some form of computer control over these things. Now, what it really boils down to at the end of the day is I like how Wes was bringing up PLCs, the programmable logic controllers, that basically you say, hey, I need this device, which is a fancy electronic or pneumatic valve to open, and then I need it to close. But I need to do it at a very specific time in a very specific way under very high pressures and with very dangerous levels of contaminants or something to that effect, right? That's typically what we're thinking of when we think of ICS and SCADA. SCADA is the supervisory control and data acquisitions. Now you're like, whoa, that's a lot. That's a lot of acronymage going on there. You're right, it is. I don't blame you for going like recoiling like it was a rattlesnake. I can't stand all the acronyms, but we tend to rely on them, and we do need to be familiar with those. Now, when it comes to SCADA, think of ICS as like an umbrella term, right? We have these industrial control systems. Here are the types of things that fall under them, and SCADA is kind of like this subset of ICS, where I have a large controller room is very typical to be thought of that has access into my ICS systems. And that's where I will retrieve data. I will get that information. I will be able to control PLCs, reprogram them, do certain things, get all that information, all the telemetry data comes in, and I have one-stop shopping. There's also DCS, which is a distributed control system. And that is a little weird that they name it that way. Because you think, oh, it's distributed. But it's distributed control system. Think of it that way. So where the control for these large scale systems will be done on site instead of controlled centrally at a centralized area inside of a large room. Hey, I have control of this, and this. It's I have to go over here, and to control that thing, it will be on those premise, right? So that would be a DCS. So keep that in mind. Not centrally controlled if you're talking about DCS. All right. Other things that you typically use with SCADA systems are something called a HMI, or a human machine interface. A lot of times this will be a touch panel, I can say that correctly, giving you the ability to configure or reprogram or read information from the system. All right, and these are the main components that work with this. Now, HMIs don't have to necessarily be a panel. It doesn't have to be some sort of like thing. It could be software. It could be an application. And a lot of times that's exactly what it is. You have an application, and that's how I'm going to interface with my control systems at large through that application.
You know, and some people might not think about it, Dan, but these a lot of times are embedded systems, and they're highly proprietary, which means one company owns it. So there's no system, or I should say standard way to interact with them, right? Well, we're talking embedded systems, microcontrollers, right? So we need that a specialized interface to be able to actually control these devices.
Yeah, but that being said, the systems that control the system might be specialized, but the avenue in which they use them could be the same. And this is where it starts to get us into the main types of threats, because Modbus is the controlling system that is typically used in SCADA-based systems. This is the language in which they speak for sending and receiving information, right? So as a network application protocol, it is used to read and update instructions and configurations, that Modbus. And like I said, this is really where the metal meets the meat when it comes to threats, because Modbus has been around a little while, and typically when that occurs, then, there's going to be some security issues for things that have stuck around for a long time. If there hasn't been major updates to these systems, you're probably going to need to look out for that stuff. So let's move into that category. Let's move into threats per se for these systems. All right, so we did talk about having applications, right? Software applications that allow us to interface with these systems. Here lately, more often than not, we are connecting these things to networks and even the internet, right? The internet. And because of that, and because there's probably the application that you are working with is a lot of times nowadays also a web application. So I'm going to connect through a web application, and through that web application, I'll be able to update configurations, make changes, do whatever I need. I'll interface with my industrial control systems. That just brings us right home to, well, it's a web application. I know web application threats, and you can take those web applications. So injection attacks, command injection, SQL injection, you name it, that is all, throw that in the bin, right? If you have any kind of sensitive information disclosure or bad authentication or broken authentication, guess what? If you have to authenticate to the thing and you have a poor mechanism for doing that, then you have a threat to the system. Because if I'm then therefore able to gain control over the system in some way, shape, or form through these standard threats in which we see every day, just walk down the OWASP top 10, and probably one of those things is going to be a problem for you. Well, hopefully not, but it does happen. Then I'll be able to gain access to the system and do whatever I want. And a lot of times when we're talking the threat actors that are after these type of things, they're not good people, because if something happens catastrophically inside of a SCADA system, it could result in loss of life or limb. And that's a human cost. I'll pay money all day. I can lose money. We can go out of business even. As long as people aren't being hurt, I'm happy. I can call it a good day at work. And when you're working with these types of systems, a lot of times it can result in that kind of thing. So think of the people that would be going after that and what their motives and intentions would be. They aren't anything good, right? So it's really important that we keep these systems as secure as possible. So there's the first real threat, is that you have some sort of software application. So all the standard fare, buffer overflows, injection attacks, you name it, that's all a problem with those applications themselves. But then we move more into the Modbus protocol that's used for connectivity, right? So I went out into the webs and I was looking for a really good resource for you good folks out there. I think I found a great one here. The vulnerabilities of the Modbus protocol, submitted by Evangelio. I hope I got that correct. Interesting name, but looks Greece, because there it says Piraeus, Athens, Greece. Great article. I found it to be excellent. It is not in Greek, by the way, so don't worry. There's a little bit of Greek like up here, but this is all in English. So if you're an English speaker, you should be fine. But what we would be looking for would be like right around here, vulnerabilities and attacks against Modbus. So let's just click on that. Modbus is the most widely used SCADA protocol. Supervisory control and data acquisition protocols are communication protocols designed for the exchange of control messages of industrial networks. So several hundred of these protocols have been developed for serial LAN, WAN. So you start to see this communication that's outside of the no more air gapping. It's really nice to be able to just stick a cell card on this thing, and it also opens it up to these attacks. So here they just really did us a great service of giving us kind of a laundry list of things that we need to be aware of, and it's super helpful and apropos for what it is we're talking about today. Lack of confidentiality, lack of integrity, authentication, right? Simplistic framing, lack of session structure. It also goes into talk about how the Modbus TCP protocol contains a vulnerability that would allow an attacker to cause denial of service attacks. So if I'm able to get control of this, because all this is done through clear text. Yay, love clear text. Unless it causes, lack of security that causes loss of human life, that could be bad. So clear text, I can just, if I'm on the wire in any way, shape, or form, I'll be able to look at that. I could then do a man-in-the-middle attack, possibly do a denial of service where I'm maintaining a valve in an open position, right? I've told it to stay open. Now that service doesn't work right. They've got to stop production for whatever reason, fix the issue, and then get back to work. So you have that denial of service, that kind of stuff. The other thing is that I can do other things. I can think of Stuxnet. Stuxnet is always like my favorite example of SCADA and ICS malfeasance, because what did they do? Wes, you're familiar with Stuxnet,
Absolutely.
right? Correct me if I'm wrong. Iranian nuclear facilities.
Yep. They
were destroying them,
and it wasn't just a proof of concept thing like we've seen where it's a war game.
Right.
This was actual. They could get in and they could modify the inner workings of nuclear systems.
Right. And what they were trying to do was basically they would report. So let's say Wes is my Iranian nuclear physicist. He's running his little show there and doing his thing. He's looking at his SCADA system, which is telling him all about these centrifuges. And it's saying, everything's great. He's like, I love my job. This is fun. I get to work with nuclear stuff and I'm having a great time. But what's really happening is, hey, that thing is broke. I mean, this says it's fine, but it's broke as broke can be. What's going on? And that was the Stuxnet malware. And it was basically reporting back to Wes that things were okay, but it was actually spinning up those centrifuges beyond their capabilities and doing it for certain periods of time, just enough to where it would start to unhinge itself and break, and it would just look like a random failure. And that put their nuclear program back by months and months and months. But if you were on the other side, if you were Iran, or if you were so-and-so, if you were such and such, and you had these systems and someone were able to gain control over them, I could send all sorts of information, tell it to do certain things. I could send information back to you that told you everything was fine. I could send information to do things it wasn't designed to do, or go outside of its capacity and its limitations. So hopefully either break it or just cause problems for you, because that's the whole purpose of attacking these types of systems. So there you go. These are the good news is they have started to implement some TLS inside of the Modbus protocol. So now there's some security wrapped around it. We just have to start implementing it. I'd want to say that was implemented as of the end of 2019 or at the beginning of 2020, if I was reading correctly. But just be aware, there is a secure protocol for that, so we should be using that. That would be a good mitigation against threats. If you can start to implement those more secure systems, it's always a good thing. I'm trying to see if there's anything else, or if I can remember anything else that I need to think of. Remember, DOS attacks. I highly recommend this lovely document that we were just looking at. It's not a long read. It's a very informative, and it's really well written. I'll be honest. I really enjoyed it. Kind of gave me a little more thought process and information about SCADA systems as well. But I think that's it. Remember those attack types. Remember the different types of threats, and that there is some mitigation for us to work with those, because that's what you're going to need to know for the exam itself. And if you're working on the systems, probably good news you could use as well.
Yeah, Dan, and this isn't just like, again, I always say the tinfoil hat thing where you're like, oh, be afraid, and we've got no examples. Now, there are remote access Trojans that are in the wild. In fact, one just dropped yesterday. We're in the middle of April here. Dan, can you speak a little bit to that?
Yeah, Wes actually just sent me an article here. Let's check it out together. I'm going to paste this URL in from the Hacker News. Make it a little... And it is. Look at that. COVID-themed lures target SCADA sectors with data stealing malware. Oh, the old coronavirus.
And it's interesting how they're doing this, right? They're piggybacking off an exploit, probably macros in Word, right? We should always disable macros. No, you should never disable or you should never turn on macros, right? And that's how this is kind of propagating. But it's allowing them to install something like a remote access Trojan that they could turn around and steal your information, or steal the information from the SCADA system. So I thought that was kind of interesting that it happened, just yesterday, and we're filming this today.
Oh yeah, this is good stuff. This is exactly the kind of article that you need to be apprised of if you're working in these systems. And that will just kind of help you get more context, if you don't work in these systems, give you more context around this idea of what's going on, what the threats that surround us. So great article, Wes. The fact that you're dropping a rat onto an industrial control system, that's a big deal. If I have remote control, I don't even need to have some like packaged malware that is supposed to do X thing, and then I'm all hands off. This is, oh, thanks for the access from my house, and now I can do whatever I like. That's a scary, scary proposition. I'm gonna have to read this article. It looks really good. Making registry modifications to gain persistence. This is the whole 9 yards.
And they got the C2 in there. They talk about how the C2 was established and stuff. And basically, it's an exploit on an VB script, where for people that are not disabling macros, and they're able to gain persistence.
Well, didn't Microsoft like stop disabling macros?
Sure, they did.
Like.
I'm not sure
last
actually.
year or something. Yeah,
oh, really?
Like macro attacks aren't a thing anymore, so we'll just go ahead and re-enable macros by default. I was like, that is dumb.
That's right.
That is dumb.
So this is a very real situation that you'll have to deal with as a cybersecurity analyst. So be aware of these systems. Be aware of the moving components, but then the threats that are associated with things like your industrial control systems, your distributed systems, if you will, SCADA systems, and then be aware of that Modbus protocol that Dan has pointed out. We've got a lot more to talk about in CySA Plus, but we don't have a lot of time in this episode. So ladies and gentlemen, thank you for joining us, and we hope to see you in some of the upcoming episodes.
Thank you for watching IT Pro TV.